had to put my plane down to carry out some repairs. I've made a base in a cave, but it's a land full of unexpected danger from weather and wildlife.
Oh, phew. Oh, that was close. Now, one experience I don't want out of this place is what it would be like to be part of something else's food chain. Now, what is this? Half-eaten food and... oh, looks like mouse droppings. Boffin. I might have guessed you wouldn't be far away from here. And what's that? Boffin! 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 There's another food chain in action. Boffin! Boffin. Science line. How can I help?
Stella, we were wondering something.
When you have a good look around a garden or field, you find thousands of insects, but only a few birds.
Yeah, like sparrows and blackbirds. And you hardly see any birds of prey.
Like hawks and kestrels.
I reckon it's because hawks have to hide to try and hunt the smaller birds.
But if there were as many hawks as sparrows, there wouldn't be enough food to go around, would there?
So I guess what we're asking is, why are there more smaller living things than larger ones, Stella?
I'm onto it. It's all to do with food eaten by every living thing on the planet and the energy in it. Now, energy gives all living things the means to do anything. I'm using energy now to walk and talk. But where does that energy come from? Well, food, yes. And food is an energy store from the sun. Now, I can feel some of the sun's energy as heat. But for me to be able to use this energy, it has to be transferred to the food that I will eventually eat through a chain of events. This chain is called a food chain. Now, all living things on the planet are part of the food chain, but whereas animals need to eat food to get their energy, green plants can produce it themselves by photosynthesis. And that's why they're always the first thing in the food chain.
Here's an example of a food chain. Energy from the sun is stored in plants. Snails eat the plants. Then they get eaten by small birds. Smaller birds are eaten by larger birds of prey.
So the energy is passed on or transferred from plant to snail, from snail to smaller bird, and eventually ends up in the larger bird. But it's often not as straightforward as a simple food chain, as Howie's going to find out.
Beautiful. To us, this looks great, but to some things, it tastes great too. Slugs and snails are one of a gardener's main pest problems, and this is one way they're controlled: poisonous slug pellets.
But I'm here to investigate how slug pellets like these can affect more than just garden pests.
Pippa Greenwood is an expert on garden pests.
Wow, what's happened here?
Well, this sea cow's been absolutely wrecked by slugs and snails. Look, they've had a real banquet.
Incredible. I can really see why their numbers need to be controlled.
Yeah, but the problem is most people use slug pellets and they kill far too many slugs and snails.
But a lot of birds depend on slugs for their food.
Yep, lots of birds love slugs, and as you know, song thrushes are expert snail killers.
If there are fewer slugs and snails, that means less food for those birds.
Yeah, and it's not just birds, is it? Because slugs and snails are really important in lots of different food chains. Come on.
So slugs and snails must feature in more than one food chain.
Look.
Oh, brilliant. Look at that. A hedgehog looking for tasty slug and snail snacks.
And imagine a big hedgehog like that, you'll probably get through quite a lot of slugs.
A phenomenal amount, I should think. It's funny, isn't it, though, seeing one out and so lively in daylight.
So a hedgehog also gets its energy from eating slugs and snails.
So hedgehogs, birds, they depend on slugs and snails. But there are other animals too, aren't there?
Yeah, frogs, toads, slow worms and badgers.
And they're all part of their own food chains. You're going to have plant, slug, and then frog.
Or badger, or toad. So the simple chain's getting a bit more complex.
Yes, but remember they're not necessarily the top of the chain, because, for instance, crows will eat frogs.
And foxes. Foxes will eat frogs as well. So what you've got is not one food chain, but a whole load of food chains all interlinked and dependent on each other. It's a bit like a web.
So our simple chain has gone. Plants are still at the first level, but now slugs and snails are in the middle of a web, with these things dependent on them for energy. Frogs and toads, badgers, hedgehogs and thrushes. And these dependent on those things. Foxes, owls, crows. If there aren't enough slugs and snails, everything else in the food web is affected. Right, I'm glad that's sorted, because all this talk of food has made me a bit peckish.
So energy is passed on through food webs and chains. But how much is passed on? Well, if we use this spot of sunlight to represent the sun's light energy shining on a green plant, how much does the plant manage to convert to stored food energy? 66%. 33%. In fact, this much, 0.2%. Only 1/500th of the sun's light energy is transferred to the start of a food chain.
So if all the energy that's stored in the plant and is available to the animals that eat it is represented by this light, how much is transferred to that animal? 90%? 50%? No, the amount of energy transferred to the animals is around 10%.
But what happens to the 90% that isn't? Well, it's not available to the food chain because it's the energy the plant needs each and every day to survive. And it's the energy that drives all the reactions to make new cells, which in turn produces leaves, flowers and seeds. In fact, all levels of the food chain only transfer 10% of the energy they receive onto the next level. So what happens to the energy that isn't passed on in an animal? Another one for Howie.
Here in the wild, amongst Asian deer, on another Science in Action investigation, it's the Howie.
In the wild, deer like these are part of a food chain that has tigers at the top and grass at the bottom.
But in eating a deer, a tiger would only get 10% of the energy the deer had consumed.
It's the same for all animals. So where does the rest of that energy go? Grubs up, deer!
So that's the question. What happens to the missing 90%? Feeding's not all about taking in energy. Whilst these deer get their food delivered, in the wild they'd have to use energy looking for it. Then there's the process of eating. Chewing the food takes energy, and so does digesting it. And no one knows better than the Howie that the undigested food ends up as dung. So feeding is the first thing to use some of the 90% energy that's not available to the next level. And so the Howie moves on, stopping only for a small drink.
And here's another way that animals use energy. Breathing.
The muscles an animal uses to breathe are working all the time, and that takes energy. Breathing means the body can use oxygen in the air to release energy stored in the food that's eaten. This process of energy transfer is called respiration. The second energy use then, respiration.
Actually, all this water's made me want to, you know... Excuse me. Oh, another way that animals use energy is through excretion. Excretion is the way the body gets rid of things it's produced, like through sweating or breathing out or having a wee. Excuse me.
So another energy use is excretion. But what about the clatter of tiny hooves?
Reproduction takes a lot of energy. The animals mate, the mother has to provide enough energy for the baby to grow inside her, then after birth, the youngster's got a lot of growing to do, and it needs looking after.
So reproduction needs energy, and so does growing. Animals use energy all the time for living and responding to what's going on around them. And when it comes to surviving, they really have to move. So finally, responding and moving. They got away.
But not all of them do, and the tiger needs that energy, even if it is just 10% of what the deer had.
So there's the available 10% of the energy, and the missing 90% goes on the life processes, the things that living is all about for all animals. Even the Howie, known chiefly for his gibbon impression. Apologies to gibbons everywhere.
So, each level of the food chain has less energy available to it than the one above. And we can see this when we work out how many organisms are needed to make a food chain work.
Let's look at the quantities of organisms in this chain. Most energy stored in this grass is used to live. 1/10 is transferred to this rabbit. The rabbit uses most of the energy on the life processes, and so 1/10 of it is available to this fox when it eats the rabbit. Right, let's look at some numbers. The amount of energy the fox gets from one rabbit is not enough for it to live. One fox eats 70 rabbits to live a year. How much did the 70 rabbits eat to live? 20,000 blades of grass.
We now have another way of showing the decreasing energy being transferred from the start of the food chain to the end.
20,000 blades of grass support 70 rabbits, which support one fox. This is called a pyramid of numbers.
I was right. There are fewer animals further up the chain because they need more below to eat.
If only 1/10 of the energy gets passed up each time, the energy available to the next level gets very small, very fast.
So is that why there can only be a few links in the chain, Stella?
Right. But is there any way of making the transfer of energy from one level to the next more efficient? Howie needs to investigate.
Well, that's an owl box. And look, an owl pellet. Fur, bones, all the parts of an owl's small mammal dinner that it just can't digest. So, I'm definitely in the right place. So where's Colin Scheuer? Psst, Howie. Look.
Barn owls like this are under threat. They're not producing enough young to keep the species going. I'm here to investigate what's being done about it.
So why aren't barn owls producing enough young?
Well, to understand that, we've got to look at their food chain.
OK. At the bottom you've got grass, and that's eaten by small mammals like voles and mice. And the voles and mice are, in turn, eaten by the barn owls.
Yes, but it's the number of small mammals that's so important.
Right, because the number of small mammals will directly control the number of owls that can live in a given area.
Exactly.
And the less mammals there are, the longer the owls will have to hunt.
That's right.
So how many small mammals does an owl need?
Well, an adult owl needs about 3 small mammals a day.
Right.
Owls like to hunt up to about 1 kilometre from the nest. If there aren't many small mammals around, the hunting is very inefficient. They have to fly a long way just to catch enough food for themselves.
So, although they could catch enough food to feed themselves, there's no way they can get enough to raise a family.
Exactly.
So why is there such a shortage of small mammals? I mean, there's hardly a shortage of grass. It's everywhere.
Yes, but it's not the quantity, it's the quality of rough grass. If we look at this area here, it's all short, close cropped, well grazed, and voles can't make their nests, they can't make their runs, and they can't hide.
So as this grass is too short for small mammals to live in, it means there's not enough food for owls. So the owls won't breed.
Yes, they won't breed and the species will die out.
So what the owls need to do is move to an area where hunting can be made more efficient. Well, somewhere suitable for small mammals.
Yes, come on, I'll show you.
I guess that means grassland that would give them good cover.
Well, this meadow is excellent because there's this rough, tussocky grassland here, where I'm sure if we look hard we might find vole run. Yeah, here we are. Here, look. Here's a vole run, and in here are the small clippings of grass, which is their food store. So this area is alive with small mammals.
Look what good cover this grass gives, meaning the small mammals can breed, increasing the food supply for the owls. Colin's monitoring the number of small mammals using traps which catch them alive.
Right, shall we see if we've caught anything?
Yes,
There he is.
a wood mouse.
So how many small mammals like this will a family of owls need to eat in a day?
About 20 small mammals in one evening, and about 15,000 in the breeding season.
That's an incredible number.
It is indeed, and that's why they need rich habitat.
With more small mammals around, the owl can hunt more efficiently and catch food not just for itself, but for a whole family. Colin's put an owl box here as there are no natural nesting places in the area. These are young owls, which shows the parents are breeding. They're checked to make sure they're growing into healthy adults. It won't be long before they fly off for good, and soon they'll be starting families of their own to continue the species.
Here's a question for you. This is another food chain and the numbers involved. One hawk lives off 15 missel thrushes, which live off 500 snails. But how many lettuces do the snails need?
Well, it must be more than 500 because of the energy lost through the chain.
Yeah, but lettuces are bigger than snails, so wouldn't that make a difference?
Stella, we don't know.
Well, the answer is
100 lettuces. Now, why do you think that is?
Fewer lettuces than snails. That's not how it's meant to work.
No, energy's lost at each link of the food chain. So there should be more lettuces than snails.
Yeah, but hang on, what did I say before?